Today my group will be doing the effect of baking soda plus with vinegar with fire. All you need is baking soda, vinegar, a mug or a glass, a lighter and a candle. So all you need to do is add the vinegar and pour in the baking soda equally. Then you light up the candle, and what will happen is when the gas created by the baking soda solution will be poured on top of the candle, later extinguishing the fire. This is proof that oxygen supports combustion and that carbon dioxide does not support combustion.
In this experiment, when baking soda and vinegar mix with each other, they make a chemical reaction. This is because baking soda is a bicarbonate and vinegar is an acetic acid. When they react with each other, they produce carbonic acid. However, carbonic acid is very unstable and it quickly decomposes into carbon dioxide and water. The bubbles you saw inside the container were full of carbon dioxide. When pouring the container, you literally pour the carbon dioxide onto the flame. That means air can get to the flame and it goes out due to lack of oxygen.
The next experiment we're conducting is colored flames. So the first ingredient and the most important one is methanol. This thing acts as a base of the whole experiment. Next you need borax or boric acid, salt substitute, table salt, calcium carbonate, and lithium batteries. So to do this experiment, you must have an ashtray or any bowl of sorts that will make sure that the methanol you would pour in will not spill. So first things first, you have to take any of these things. I'm going to use salt substitute as an example. So I'll pour in a bit of salt substitute on top of the tray itself. Then just put in a few drips of methanol. Only a few drips, remember that. And then make sure you mix it so that the element itself is fully coated with methanol. Then after that, all you have to do is just light the thing on fire and voila, a colored flame. This is to prove that different elements will emit different wavelengths that can be discerned by the human eye. For example, lithium battery, the way we see it when it's burnt with methanol, or anything really that's flammable, we see it as a color of red. And if you burn it at even extreme heat, it'll be a silver color.
Wow.
I can't tell that one was genuine.
So basically, why each chemical emit different flames when burned is because the ions are heated in a flame to high temperature, causing the electrons to enter an excited state from the heat energy absorbed. Thus, the electrons move to higher energy orbitals, causing the electrons to change its wavelength of color. The energy emitted from the electrons will give out the wavelength of light corresponding to it. Methanol is used as a base to burn the chemicals is because methanol is highly flammable, causing the heat to react with the methanol first. Methanol serves as the fuel to ignite the chemical's flames as it has a low boiling point compared to the other chemical compounds. Without methanol, it will take a longer time for the chemicals to burn, and the results of emitting its wavelength color may not be accurate.
Some fire. Go.
Okay, it's done here. Oh my god, it's so live.